2016, paper 2, question 2, circle. So in question 2 here we have a point x which has coordinates -1, 6, and the slope of the line from x to the centre of the circle S is given by 1/7. So the first thing it asks us to do here is nice and straightforward. Find the equation of xc, and we have to write our answer in the form of ax plus by plus c equals 0. So in other words, we can't write it in the form of y equals mx plus c. So to find the equation of a line, we use y minus y1 equals m times x minus x1, which can be found on page 18 in our maths tables, where we have the equation of the line. So by subbing in our point, we have x1 and y1, and then we have m is a 7th. So we have y minus y1 equals m times x minus x1. So I'm going to multiply across by 7, so we get 7y minus 42 equals x plus 1, bringing everything then to one side so we can get it in the form of ax plus by plus c. We then have x minus 7y, and then that's going to be plus 43 equals 0. So a nice easy start to the question and a very handy 10 marks. So for B, we're told that C is the centre of a circle S of radius 5, and the line L is a tangent to S and passes through X, as shown in the diagram. So in this diagram here, and we have to find the equation of one such circle S. So really there's two possible answers here, because obviously we could have two circles, one on either side of this tangent, but you're only asked for one answer. So we can get two possible values, but we only need to write down in our final answer one circle. So based on the information provided in the first diagram, we were told 5 centimetres, we had x to c, and of course if there are two possible circles, that means they're identical in size, and meaning that there would also be both radius of 5 centimetres. So what we've just found is the line XC. So obviously that line will pass through both centres. In other words, the centres are contained on that line XC. And we know that the equation of a line with centre minus g minus f must be on the line XC. So in other words, if we take our line XC, which we've just established is x minus 7y plus 43, then I can sub in 4 minus g and minus f, and I'll get equation in terms of g and f. And we'll call that equation 1. So to get a second equation, because we have two variables, we need a second equation to do our simultaneous equations to solve for f and g. Well, if we look at our diagram, we can see that we have 5 centimetres the radius, which is of course perpendicular to the line XC. And again, it doesn't matter which circle I look at, the radius will always be perpendicular to the tangent. So therefore we know that our perpendicular distance is equal to 5 centimetres, which is perpendicular distance to the line L. And therefore, if we're looking at our maths tables, which is page 19, then our perpendicular distance is given by that formula there. So we say A times x1, B times y1 plus C over the square root of a squared plus b squared. So of course we need to write down what's A, what's B, what's C, what's x1 and what's y1. So obviously the x1, y1 is going to be our center point, which is minus g minus f. The line L is 3x plus 4y minus 21 equals 0. So that means that A is 3, B is 4, and C is minus 21. And of course, we've said our perpendicular distance is 5. So subbing in there, we have x1, y1 is going to be our minus g minus f. So that's 3 times minus g plus 4 times minus f minus 21 all over the square root of 3 squared plus 4 squared. So we have 5 is equal to minus 3g minus 4f minus 21. And the square root of 9 plus 16 is the square root of 25, which is of course 5. So therefore, if I multiply everything across there, both sides, by 5, I'll get 25 is equal to minus 3g minus 4f minus 21. So this is a modulus equation. So we can either say that all of that is equal to 25 or minus 25, or you can square both sides. Either way, you'll be able to solve this equation. So I'm going to take the fact that the modulus is going to be plus 25 or minus 25. So we have minus 3g minus 4f minus 21 equals 25, or minus 3g minus 4f minus 21 equals minus 25. So this is obviously our quicker way of solving these two equations. So we have minus 3g minus 4f is equal to 46. Or we have minus 3g minus 4f is equal to minus 4. Okay, so this is where we're going to get our two possible solutions, because we can obviously take 1 and 2 to solve, or we can take 1 and 3 to solve. So I'm going to show you the two separate solutions, because it depends on which equation you would have chosen to see which circle you would have gotten. So I'm going to do both, even though in the exam we would only need to give one circle. So we have minus g plus 7f. So you have to take minus g plus 7f equals minus 43. And then if I take minus 3g minus 4f equals 46, that means I'm taking equation 1 and 2, okay? Or you can take 1 and 3. Okay, we wouldn't be able to take 2 and 3. It has to be the first one and one of the second two sets of equations we got. Okay, sorry, I need to get rid of those lines there. All right, so we're going to get rid of, I'm going to go for getting rid of g here. So I'm going to multiply the top line by minus 3. So that gives me 3g minus 21f is equal to plus 129. So 3g minus 3g is 0. And we have minus 25f is equal to 175. And therefore f is equal to minus 7. So what that means then is that my center minus g minus f is going to equal, I'll have to sub back in here for g. Sorry, I need to get rid of that bit. We'll sub back in for f first of all. So sub f into 1, That gives me minus g plus 7 times minus 7 equals minus 43. And therefore we have minus g minus 49 equals minus 43. Sorry. And therefore g is equal to minus 6. So that would give me the centre of the circle minus g minus f would be equal to 6, 7. Where if we took the other set of equations, and again if I multiply the first one by minus 3, well that gives me 3g minus 21f is equal to 129. And then we have minus 3g minus 4f equals minus 4. So minus 3g and plus 3g is 0. Minus 21f and minus 4f is minus 25f. And 129 minus 4 is 125. And therefore we get f is equal to minus 5. And if I sub f into 1, then I get minus g plus 7 times minus 5 equals minus 43. So minus g minus 35 equals minus 43. And therefore g is equal to 8. So that means my centre for the other circle, minus g minus f, is equal to minus 8 plus 5. Okay, so we need to write down then the equation of the circle. So even though I've found minus g and minus f, I already have the centre, so I don't need to find c, and therefore I don't need to use this format here. I'm actually going to go with the easier version, which is x minus h squared plus y minus k squared equals r squared. So if we take the first circle, circle 1, well, we know the radius is 5 centimetres, and we've just established that the centre we said there is 6, 7. So therefore that's hk. So we can say the equation of the circle x minus h squared plus y minus k squared equals r squared. So therefore you should have x minus 6 squared plus y minus 7 squared equals r squared. So 5 squared is 25. So that's a fully correct answer. Or if you had taken the other two equations, we would have gotten circle 2. So again, radius was the same, so 5 centimetres, and centre we worked out to be there minus 8, 5. So hk. So that would give us x minus minus 8 plus y minus 5 squared equals 25. So in other words, the second circle that you could have gotten there was x plus 8 squared, y minus 5 squared equals 25. So as I said, you only had to give one of these circles, not both. Okay, so we would have taken either one or the other. So there's 15 marks going in total for that second part. So for B, so we had 0, 4, 7, 11 and 15. So again, most of your marks were going for getting those GF equations. And then to solve and write down the centre, you were getting your full marks.